Okay, so this is going to be the next video in the Unit 1A assessment review. Okay, so you should have just seen the number system review video, okay, where we talked about rationals, irrationals, and whole and natural numbers, okay? So maybe we could do a little check mark there. Okay? So now the next item on the list is converting decimals to fractions, okay? Specifically converting repeating decimals to fractions. And that's what we're going to look at right now, all right? So let's go ahead and look at that for a little bit. Okay, so here we have converting repeating decimals to fractions, okay? So first things first, when it comes to decimals, we really have to understand this first statement, okay? So we need to understand that every number has a decimal expansion, okay? That was one of the essential questions for this unit, okay? We have to know that, okay? And it's pretty obvious, okay? Every number has a decimal expansion. For example, okay? What does that mean first? So what does it mean that every number has a decimal expansion? Well, it means that any number can be written as a decimal, okay? Any number can be written as a decimal. That's all it means, okay? So, for example, we have 4. You can rewrite 4 as a decimal, 4.0. Okay, these two are equal. Pi, right? Pi is a decimal. Pi is irrational, so it's definitely a decimal. It's 3.14159, right? It keeps going, but it's a decimal. Square root of 2 is irrational, but it's still a decimal, okay? And it goes on forever, all right? So yeah, these three numbers these can all be represented using decimal expansions, okay? So right now, let's look at a converting to a fraction example. So the first example is going to be what is 0.7 repeating as a fraction, okay? And notice it's just a single digit that's repeating, okay? It's not two numbers or three numbers, it's just a single number. In this case, it's just 7, okay? So for example, maybe we'll look at this real quick. We'll say 0.7 repeating is equal to 0.77777, right? Goes on forever, okay? That's just 0.7 repeating, okay? Now what we want is 0.7 repeating as a fraction, all right? So remember, the first thing we did was we said let x be equal to that number, that decimal, that repeating decimal that we want to turn into a fraction. Let x be equal to it, okay? Now the next thing we did was we said that since it's only one number, in this case it's only a 7 that keeps on repeating, okay? Since it's only one number that's repeating, all we have to do is multiply both sides of this equation by 10, okay? So we get 10 times x is 10x, and if you take 0.77777 and you multiply it by 10, right? We're multiplying both sides of this equation by 10. 10 times x is 10x. 0.7 repeating times 10, if you look at it over here real quick, all you do is move the decimal once to the right. Because you're multiplying by 10, there's 1 0, okay? Just move it once to the right, okay? So we get 7.7 repeating, right? Once we move it once to the right, all these 7s are still going to be there, so we're still going to have the 7 repeating, okay? Now the next step we said was to subtract this equation from this equation. So we do 10x, which is equal to 7.7 repeating, minus 1x, which is equal to 0.7 repeating, okay? We subtract these two. 10x minus 1x is 9x, which is equal to 7.7 repeating minus 0.7 repeating. Well, these 7 repeatings are going to cancel each other, right? Because when you think about it, when you do 0.7777 minus the 0.777, they're all going to cancel out, right? 7 minus 7 is 0, 7 minus 7 is 0, 7 minus 7 is 0, okay? And it's going to keep going on like that, and you're just going to get 0. So here we just end up with 7 minus 0, which is 7, Okay, all these 7s go away. So now what we want here is we want x by itself. Okay, so to do that, we see here that we have 9 times x equals 7, right? There's really a times there. Okay, not a big deal. And to get rid of the 9, we do the inverse operation. So since it's 9 multiplied by x, 9 times x, we're going to do the inverse multiplication, which is division. And that means divide both sides here by 9. The 9's on this side will cancel out to equal 1x, but we don't need to write the 1, okay? It's assumed to be there. And we just get x equals 7 over 9. And that's our answer as a fraction, okay? Now please note this, the commonality between x equals 7 over 9 and x equals 0.7 repeating, okay? So realize that this says x equals 0.7 repeating. But if x equals 0.7 repeating and what we just did yielded x equals 7 over 9, then that means 0.7 repeating is 7 over 9, okay? So this is the entire purpose of what we did, was to get this guy as a fraction. So 0.7 repeating as a fraction is 7 over 9, okay? Just please note that these two are equal. All right, that's the reason we did all of this, okay? Let's look at another example. Okay, so this example says convert 0.48 repeating to a fraction, okay? So before we only had one number repeating. Now we're going to have two numbers repeating because the bar is over the 4 and the 8. So this, if you were to expand it, would look like 0.48, 48, 48, 48, okay? Goes on forever, okay? So we want to turn this into a fraction, all right? So the first step's always the same. We always let x equal the decimal, okay? 0.48 repeating, all right? Now the next step is to look at and see how many digits are repeating. Okay, and we need to be careful, okay? So since the bar is over the 4 and the 8, we know it's 2 digits that are repeating. 4, 8, 4, 8, 4, 8, 4, 8. Okay, it's 2 digits, the 4 and the 8. So that means we need to multiply both sides of this equation by 100 because it's 2 digits. So now we're going to get 100 times x, which is 100x, equals, if you take 0.4848, 0.4848, 4848, 48, repeating, and you multiply by 100, well, that just means to move the decimal point twice to the right. So here we're going to get 48.48 repeating, right? Because once we move the decimal, we're still going to have the 4 8s, 4 8, 4 8, 4 8. Now what we can do is what we did before in the previous one. We can subtract this equation from this equation. Okay, so we're going to do minus x equals to 0.48 repeating. 100x minus 1x is going to give us 99x, which is going to be equal to what happens with these 48 repeatings. Well, think about it. If we were to subtract these, we would have 48, 48, 48 minus 0.48, 48, 48. 4 minus 4 is 0, 8 minus 8 is 0, 4 minus 4 is 0, 8 minus 8 is 0. So these are all just going to go to 0, so we can just cancel them out. So we'll just be left with 99x equals 48. And same thing as before, we need to solve for x, okay, because we have this up here, and we want it as a fraction. X is by itself up here, that means x needs to be by itself down here, so we can see what this is as a fraction. So to do that, we'll divide both sides by 99. The 99s will cancel to equal 1, not 0, 1, because 99 divided by 99 is 1. So we'll get x equals 48 over 99, okay? Now, in this specific problem, we can see that maybe it's not that obvious, but what you want to do is you want to check, okay, especially on the test. Just because you arrive at an answer like this, it might not look like this. Your option choices might not contain the 48 over 99, right? It might be simplified. Okay, one way to look and see how to simplify this, and a number that I really encourage you guys to always check is 3. Okay, it's easy, and there's a little trick. So the first thing you want to do is you want to take the first number, which is 48, and you look at the digits. Okay, so 4 and 8. Well, you say, what's 4 plus 8? Well, 4 plus 8 is 12. Okay, so what you can say now is, does 3 go into 12 evenly? In other words, what's 12 divided by 3? Well, it's equal to 4. So yeah, it does go in there evenly. So if 3 goes into 12 evenly, that means 3 goes into 48 evenly. Okay, so what we can do now is we can see that we can do some long division. We'll see how many times 3 goes into 48. Okay, you don't have to do the long division if you can do it in your head, but let's just do the long division so we can see the work. So 3 goes into 4 once. 3 times 1 is 3. 4 minus 3 is 1. Bring down the 8. 3 goes into 18 6 times. So you're left with a 16 on top, right? But be careful, right? To simplify, you can't only take 3 out of the top. You cannot only take a 3 from the numerator. You have to take a 3 out of the denominator also, okay? The number that you're taking out has to go into both of them. But I'm pretty confident that 99 will factor. Let's check. So 99 is, if you look at its the sum of its digits, it's going to be 9 plus 9. Okay, 9 plus 9 is 18. Okay, that means that 3, and we can see that 3 goes into 18 evenly, right? 18 divided by 3 is 6. So if 3 goes into 18 evenly, that means 3 goes into 99 evenly. Okay, I'm not saying anything about 99 and 18 being equal to each other or anything like that. Okay, I'm just saying that if 3 goes into 18, 3 goes into 99 evenly. Okay, so let's do the long division. So 3 goes into 99, 3 goes into 99, 3 goes into 9 3 times. 3 times 3 is 9. 9 minus 9 is 0. Bring down the 9. 3 goes into 9 3 times, and we get 3 times 3 is 9. 9 minus 9 is 0. And yes, we get our answer here is 33. So our final and simplified answer is going to be, I'll write it down here, is going to be x equals 16 over 33. Okay? So now we have x by itself in its simplest form, and we can see since x is by itself here and x was by itself up here, these two are equal to each other. All right? These are equal. And now we know that 0.48 repeating is equal to, as a fraction, 16 over 33. All right? And we're going to do one more. This next one can be a little confusing, so pay close attention. All right? Here, we're going to convert 0.18 repeating to a fraction where only the 8 is repeating. Okay, so be careful where this 8's over. The bar is over. The bar is over the 8 only. Okay? So what we can do here is we can say, first things first, we do the first step is always the same. Okay, so you always let x be equal to 0.18 repeating, right? Which looks like this, right? 0.18 repeating looks like 0.1888888, okay? Because the bar is only over the 8, all right? So now the first step here is actually a combination of the previous two examples. So not only do we have to multiply by one number, we've got to generate two equations, okay? But they're pretty easy to generate, which is a good thing, okay? So the first one we're going to generate is we're going to multiply both sides of this by 100, okay? So we're going to get 100 times x, which is 100x, equals, well, what's 100 times 0.18 repeating? Well, what do you do with the decimal when you multiply by 100? You just move it once, twice to the right. So here we're going to get 18.8 repeating, right? These 8s will keep going on forever. The next equation that we're going to make, like I said, it was a combination of the previous two. So the next equation we're going to make is we're going to multiply both sides of this times 10. So 10 times x is 10x, which is equal to, when we multiply this one by 10, we only move it once to the right. So we're going to get 1.8 repeating. Then we do our subtraction, and 100x minus 10x is 90x's, which is equal to 18.8 repeating, minus the 1.8 repeating. These 8 repeatings will cancel, right? Because we're just going to have 8 minus 8, 8 minus 8, 8 minus 8. They're all 0. Okay, so they'll just cancel out. And then we'll just get 18 minus 1, which is 17. Okay, and we can divide both sides by 90. And once we do that, we can see that these 90s will cancel to equal 1, not 0. And we'll get x equals 17 over 90. Okay, and a key little note about this, simplifying this one. We don't need to simplify this one because we can see that 17 is a prime number and nothing goes into 17. So we should be okay. And that should be our final answer. And note, we have x by itself, and we have x by itself up here. So similarly as before, these two are equal. Okay, so 0.18 repeating, where only the 8 is repeating, is the same thing as 17 over 90 as a fraction. All right, and then these are some examples for you guys to try. Okay, so you guys can just go ahead and pause the video and try these examples and let me know if you have any questions. And I'll see you guys in the next video. Thanks for watching.